In this problem on PSAT prep, we're going to take a look at how to interpret the rate of change of a linear function in the context of a real-world problem. In this particular problem, we're given the equation n is equal to 436 minus 4t. And we're told that the equation is used to model the relationship between the number of cups n of hot chocolate sold and the average daily temperature T in degrees Fahrenheit. So again, notice that the number of cups n of hot chocolate sold per day, and then the average daily temperature, capital T, is in degrees Fahrenheit. And we want to know what is the meaning of the 4 in this particular equation. And so we are going to look at this equation through a table. And so if I were to create a table of values for this particular equation, I notice that capital T is taking the place of x and lowercase n is taking the place of y in this linear equation. And so if we were to just look at if the temperature was 0, obviously that would be a very cold day. We would probably expect to sell a lot of cups of hot chocolate in our coffee shop on that particular day, but let's just say that the temperature was 0. Well, if I take 0 and I plug it in for my temperature, then the number of cups of coffee sold is going to be 436 minus 4 times 0. And I know that 4 times 0 is 0, and so therefore the number of coffee cups sold is going to be 436. If the temperature is 1, then that means I'm going to plug 1 in for T to get the number of coffee cups sold, or the number of cups of hot chocolate. 436 minus 4 times 1 is going to be 432. If I were to plug in 2 for capital T, then that means that we would have 4 times 2, which is 8, and 436 minus 8 is going to be 428. If you were to plug in 3, you would see that you would get 424. And so we are able to make 2 conclusions from this table of values. The first situation that we have going on is that if we increase the temperature by 1 degree Fahrenheit, it means that we are decreasing the number of cups of hot chocolate by 4 every time. And so what we would say is that for every increase in temperature by 1 degree Fahrenheit, the number of cups of hot chocolate, and I'm just going to abbreviate that, decreases by 4. So that's one statement that we can make for this particular situation. But we can also make a second statement that sort of says the reverse of what statement 1 says. And so that sentence is going to follow the reverse logic. And so if I erase this here, what you're going to see is that if I decrease the temperature by 1 degree Fahrenheit, then what I do is I increase the number of coffee cups sold. And so I can also say that for every decrease in temperature by 1 degree Fahrenheit, the number of cups of hot chocolate sold increases by 4. And so that's what the meaning of the 4 is in that equation. If that 4 was a 6, then that means we would replace this in our sentence with a 6. And so what we see is that there is a direct variation between the temperature and the number of hot chocolate cups sold per day. That direct variation is a negative variation, meaning that as we increase one variable, we are decreasing the other one.